Three, two, one. Good evening. Back again, one last time. Sorry to bombard you with little videos. This one should only be 20 to 30 minutes, to be honest with you. I keep adding to the information because I keep getting asked different questions by different students through the formative feedback process. And each time I think, well, actually, that's a good point. And what I could actually do there is create a PowerPoint with a video to help everybody, not just the person who asked the question. So this particular question was, well, can I explicitly name the estimating techniques that you need to mention within the report? For those bits that we're talking about in relation to learning outcome 3 and 4, because fundamentally it's asking you why different estimating techniques come up with different totals, and why is there a variation. After that question yesterday, I had the question in the evening yesterday. I thought, well, let's have a look, and I thought I had sort of, forgive me because I thought I'd explained it in a little bit in a lot of detail, but maybe I just needed to be a little bit more explicit in what I meant, because when I type in Google or in Chat GPT or DeepSeek AI, list a number of estimating methods, 10, 15 come up. I even on the CIOB wiki site, there's 10, 15 different types of method. And to be honest with you, I'm only really looking for 5 or 6, 4, 5 or 6. And they're the ones that fundamentally are outlined or have a relationship to the NRM1, the NRM2, and the NRM3 even, and also the RIBA plan of works, because there is this link between them all. And fundamentally, that's what the assignments are about. That's what the unit is about, and just fundamentally understanding that. Okay. So I've called it estimating methods linked to the RICS, NRM, a critical comparison. Okay. So I'm going to explicitly name them and go through them. It's not many slides. There's a couple of tables, a couple of comparators there for you that I hope will help you all. Okay. So the aim of the presentation, fundamentally, explain key construction estimating methods. So we're looking at cost estimate, elemental cost plans, elemental cost plan with an EUR, an estimate elemental unit rate, elemental cost plans with approximate quantities, accurate quantities, and cost control, which is NRM3. Okay. So again, like I just said, like I did there in my previous, I believe my previous sort of presentations certainly cover it in much more detail, as this is just a summarization. Link methods directly to the RICS NRM stages. What I could have added in there as well is the RIBA stages as well, because we're obviously discussing RIBA stage 0, 1, 2, 3, 4, 5, 6 and 7 here as well, because we would use different NRM techniques and stages along the life cycle of the project, which is fundamentally what the questions are all asking you about. Going to critically compare them, and obviously link them back to the life cycle of the project. Okay. So that there's to show that fundamental link between the NRMs 1, 2 and 3 and the RIBA plan of works. Okay. Because there's no coincidence that they both originate at approximately the same time in the historical narratives. Okay. So an overview of the RICS NRM, I think, and I've already done this in a lot of detail. I think order of cost estimating and cost planning is covered by NRM1, NRM2, a detailed measure which will help you produce a bill of quantities, which will fundamentally help with analytical estimating. And then NRM3, cost control when the building is being used, value engineering techniques, and what all three of them fundamentally do, as you saw yourselves when you were using them, particularly NRM2, there's a very structured approach. So they basically promote structure, standardization, generalization so that we can compare, and fundamentally a degree of certainty and consistency in the figures that we produce. Okay, whether we're measuring a building or whether we are building up an estimate of some kind. Okay, so we're going to start with NRM1 and the different estimating techniques that you would use. Okay, and then we're going to move on to NRM2, and then we're going to move on to NRM3, and just a quick comparator at the end, because I've done this in a lot of detail in the previous videos that I showed you. Okay, so the first one in the NRM, right in the front couple of pages, just open the NRM one up. You know, there's a copy on Bud. Look at it. You know, the cost estimate is called. And basically, it predicts the total project cost based on the information, very scant information that you have at the time. So it's usually done at stage 0 to 1, okay, in the RIBA plan of works, used at fees to see if the building is it feasible to build this particular building? Is it feasible from a cost perspective? So, or to show this all the stakeholders, and those stakeholders could be a government agency or a number of government agencies, the taxpayer, or it could be a bunch of it could be the bank because you want to borrow some money, or it could be shareholders because, you know, rather than pay shareholders a premium, you want to invest in the business. Okay, you want to invest in your business. Okay, so the idea is to show those stakeholders that it's feasible to build this building. Okay, it's based on the quantification part of it is the gross floor area or functional floor area. Okay, so it's very, very basic. Yeah, and as I said to you, the RICS produce guidance on what we mean by gross internal floor area, what we mean by functional floor area. So again, there's a very standardized, very structured methodology to everything that we're doing. So, you know, quite scientific. You know, that's why in today's world, we're not just quantity surveyors or estimators. We are actually value engineers. We're cost engineers, you know. Low accuracy, though. That's the trouble. You're basing it on historical data. You're basing it on a series of guessworks. Because, you know, you're adding on percentages for risks. You're adding on percentages for inflation. Geographical location. So you know, a lot of it is just based, it's very generalized, it's an overview. Okay, so not particularly accurate, but it's essential to decide. You know, it'll give us a ballpark figure. This building will cost approximately £3 million or £10 million. Well, do we have that money? You know what I mean? You know, the bank is only going to let me borrow £8 million or £6 million. You know, the shareholders have just voted against it. You know, or, you know, the taxpayer, you know, has disagreed that we don't really need another, I don't know, another layer of government. So don't want another building, you know, to house government institutions. I don't know. I'm making this thing up, you know, off the top of my head. But they're the sorts of things that really the questions that you'd be asking. All right, and you'd have to sort of justify to those stakeholders. So a cost estimate is a form of estimate. It's quantified through the gross internal floor area or the functional floor area, and it's then this structured methodology, and I say to you, go and have a look at the NRM1. It's there. It's a step-by-step process. Yeah, find this. Step 2, do this. Step 3, do that. It's very, very structured, standardized. It gives you a degree of it gives you a comparator. You use historical data from SPONS or from the BCIS database to help you with the cost information. All right. And again, you would do it at 0, or you would do it at stage 0, or you do it at stage 1. The next one, you've got a little bit more information, and it's an elemental cost plan, and you're based on those 13 elements, which you can break down into sub-elements, which you can break down into components, which you can break down into sub-components, okay? But fundamentally, it's based on those 13 elements, and it basically breaks the project cost into standard building elements. Primary design stage cost control tool supports value engineering and budget alignment, because you can come up with different models based on different designs. Okay, so that helps them with budget alignment and value engineering principles. Less effective with construction methodology dominates cost, because it's very general, as you saw. Yeah. And again, based on historical documents. If you're building a community center, you would go looking for an elemental cost plan or plans using SPONS or using the BCIS database. You would go looking for ones that have been built and costed in the past, and that will give you your comparator. Then you would make adjustments for bringing it from, say, 3 or 4 years ago up to date, based on inflation, based on tender price index, building cost index. So you'd make all these adjustments, and then you were subjected to a risk analysis and add on percentages for different levels of risk. Again, those risks will be outlined in the NRM1. And again, there's a methodology, and I urge you, or I would recommend that you read the NRM1, okay, because it's all in there. Standardized, generalized, compared, consistent, a degree of certainty, okay, not accurate, but again, it'll only give you a ballpark figure. But it's breaking now the building down into 13 elements. So my God, the substructure is costing us 20%. Why is it costing us 20% of the total cost and not 10% of the total cost? It allows for that degree of analysis, that degree of value engineering, okay? And helps align with budgets, okay? So that's number 2, estimating technique number 2. Estimating technique number 3 is elemental cost plan, but you calculate an elemental unit rate. So you base it on a specific rate. With a normal elemental cost plan, you would probably find those costs from historical data, and then you make adjustments. But this time now, you have enough information to actually break the unit down, the component down, the element down, so you can come up with a unit rate. By the way, those unit rates can be historical. You can go and find them in SPONS. You can go and find them in the BCIS database. And again, it will give you a cost per unit of each building element. So each unit would be based on maybe a meter squared, and that meter squared would be based maybe on the functional floor area, or it would be based on the GIFR. Okay, the gross internal floor area. Used for benchmarking and optional appraisal. So again, coming up with different options. Okay. Quick comparison of design alternatives. That's the beauty of it. It's fairly quick. It's fairly accurate. May hide abnormal or site-specific costs. That's the trouble. It's too generalized. So there's your problem. Based on historical sort of data. So again, it sort of allows for a comparison between different designs or different building methodologies that you may wish to promote. Okay, that's the beauty of it. All right, but its accuracy is quite medium, and again, you would probably do it at phase 2 or 3 along the RIBA plan of works. A little bit more accurate is approximate quantities, so that would be an elemental cost plan with quantities, with actual quantities, but those quantities would be very approximate. Okay, however, much more detailed, does support the elemental unit rate method as well. Okay, so approximate quantities improve cost certainty, because obviously you're doing a degree of analysis now, compared to sort of purely area-based estimates, which the others are based on. So you do need a degree, you need a little bit more information. Your drawings need to be, you need to have a lot more drawings. You need to have a much more detailed specification to be able to sort of produce these approximate quants. But because you won't have all the information, you still have to base it on historical projects that are very similar to the one that you've got, a community centre, or you'd have to make some educated guesses. Approximate quantities are measures of building elements derived from design information, as I said, and used under NRM1. If you go to the back of NRM1, you'll see a similar takeoff method to NRM2. It's just not so detailed, but it's very, very similar in how you would carry out your takeoff. So you'd actually do a takeoff, but it wouldn't be as detailed. You wouldn't need to be as accurate because it's about producing approximate quantities. So suitable for cost planning, probably not best for tender pricing because it's not accurate enough, and obviously regularly updated as the design develops. So as the design develops, you get much more accurate information, and your rates will change because your quantities will change because your quantities suddenly start to become much more accurate. Good also for early value engineering options, because you can compare it to different designs, you can compare it to different approaches, the use of different materials, so it gives you that degree of comparison. And again, it follows a similar methodology to NRM2, which you saw is very, very structured. Yeah. However, you do have to make a lot of assumptions. Okay. And again, look, RIBA sort of stage 3 or 4. Okay. Then you come to analytical estimating. So the final sort of estimating style is analytical estimating, which you would use at NRM2 and NRM3. So it's anything from stage 4 onwards, because you would also use it to price up your variations, or your provisional sums in your bill. Okay, so you'd use the NRM2 if you were doing a remeasure or something. Okay, so detailed build up from material, plants, and labor. You've seen that, you've practiced, you've done a lot of analytical, or you've done some analytical estimating now. Okay, and basically forms the tender price and contract sum based on a bill of quantities that you've already measured using NRM2, or it can be a schedule of rates based. If it's NRM3, you could produce a schedule of rates or a mini bill of quantities as well. Okay, high accuracy, good transparency. Okay, but you need a lot when you did the exercise yourself. You need a lot of information. You need some really accurate drawings. Otherwise, you've got to make a lot of assumptions, which you guys had to do because I didn't give you a lot of drawings to work from. Can also be time consuming and requires a lot of information, just to reinforce what I just said there. Okay, comparison, cost estimate, fast but low accuracy, very just a ballpark figure. Elemental cost plan, strong design stage control. Okay, so you're doing it at 2 or 3, and what am I going to choose? Which design is going to work? Do I have to amend designs because, you know, it's over my budget at the moment? Okay, elemental unit rates, you can compare, but it's not accurate, but it's very comparative. And that's the same as well, by the way, with which I didn't include in there, with approximate quantities, using NRM1 for your approximate quantities. With NRM2 and 3, analytical estimating, accurate, okay, but requires a lot more time, a lot more analysis, a lot more detail, okay? And fundamentally, that's why, if you like, the budgets change over time. That's why the budgets may not reflect the tender bids, okay? And you know, that's why there's issues, yeah? Okay? All right. Life cycle perspective. Early stages focus on, is it affordable? Is it feasible? Is the design feasible? Design stages focus on cost control and value. Okay, value for money. Okay, so early stages 0 to 1. Design stages 2, 3, and maybe even 4. Tender stage, which is 4 and 5. Focus on pricing certainty, so you need a degree of accuracy, and obviously correct method. Obviously, as well. Obviously, realize, you know, tender stage also could be stage 7 as well. Okay, when you've got it in use, and you know you wish to create a tender bid situation for maybe some refurbishment or some maintenance works that's required on the building when it's in use. Correct method, okay, must match the project requirements, okay, must match those project requirements, okay. And what I've done there, comparison table, so there's a summarization of everything. I got mythos, I think it means methods, sorry, methods, okay. Cost estimate, what stages you would do it at, detail level, okay, low, medium, and high, accuracy, low, medium, and high, and obviously speed, because speed means money, okay. All right, obviously analytical estimating is the highest level of detail, is the highest level of accuracy, and you've seen that yourself by carrying out an analytical estimate and producing a bill of quantities as well, because it's linked to producing a bill of quantities, and it takes quite a lot of your time, as you can see. Key critical insight. NRM presents estimating as a progression, and that's a key word there, not alternatives. And that's the trouble. If you type it into Google, or you do something else, can you tell me the different analytical methods? They'll lay it out like it's a comparison. It's not a comparison. It's a progression. You start at 0, you do the GIFA and a cost estimate, or functional floor area and a cost estimate, and then as the information becomes more detailed, as the design starts to take shape, as the issues with the design start to get identified, your budgets start to become more accurate, because they reflect all that's going on within that design stage, all that's going on basically in the RIBA plan of works, if you read it in those early design parts of it, okay. The trouble is misuse of early estimates. If you rely on it too much, to give you a brief overview, to base your estimates on, it can cause cost overruns. Okay, so it's going to cost more. Effective cost management, provided you do it in a proactive manner, and I would suggest that you do it in line with the RIBA plan of works, and not a reactive manner. Okay, and there you go. That's all in the table there. You know, NRM1, can we afford it? The method I would use to determine can we afford it is probably a cost estimate at the beginning. Is it feasible? Okay, NRM choice NRM1, are we within budget? Let's check our budget. Elemental cost plan is a really good tool for that to devise a budget. NRM1, which design option gives better value? So you're starting to do some value engineering now. And an elemental cost plan with elemental unit rates, which you would get from those rates you'd probably get from SPONS or from BCI database, sorry. So historical nature. Is the preferred design option within budget? Because, how does it link to long-term cost control of the building? So value engineering options. And again, you can take it a stage further. You've got an elemental cost plan with an EUR, but it's actually now supported by approximate quantity. So it's a lot more accurate. So therefore, the information it's going to give is a lot more accurate. And therefore, it should you'll be able to determine whether that budget is actually affordable for you, and that design option is within your budget constraints. Once you've decided on that, you can then produce much more accurate your tender drawings, and you can then come up with an actual cost, and that's where we would produce analytical estimates. And you would probably get the contractors and the subcontractors to do that with you, because there's an argument that that's their speciality and their specializations. NRM2. So NRM2, you'd create a bill of quantities or a schedule of rates based on those quantities. NRM3 then, it's in use, and again, you can produce bill of quantities, you can produce schedule of rates. And what that allows you is cost control over the duration that you are using that particular building for that particular function. Okay, because the function of the building might change over time. Okay, as you have different people using it. What that provides is a degree of analytical estimating and value engineering. Okay, which is important in the modern world. Conclusions. Estimating accuracy increases as design develops along the RIBA plan of works because you have more information. NRM provides clear cost management framework. It's a framework that helps you produce to quantify what you need, the measurement part of it, and that accurate quantification based on very strict rules, based on historical and up-to-date information, provides for a degree of certainty and consistency throughout the life cycle costing of the project. Successful projects integrate all methods progressively because it promotes lean management techniques, to take it back to a manufacturing setting, which promotes proactive, not reactive, but proactive cost control techniques. Okay, what I would call cost engineering, where I work now, rather than quantity surveying or estimating. Okay, but it's the same term, means the same thing. And there you go, 30 minutes as I promised. Okay, cheers guys, thank you very much.